Now we're going to have a look at the application of this now. Second unit now in oxidation and reduction. I have up to now just dealt as far as here with definitions. Oil rig is the mnemonic for a definition of oxidation and reduction. You have then to define oxidizing agent and reducing agent. Can I remind you again now, please? If you're defining oxidizing agent, tell me what oxidation is. And you do fine with that. That's very important, okay? Good. And we just defined oxidation number in the last section. Now look where we're going to go with this one. We're going to define oxidation numbers and we're going to outline the rules for assigning them, right? Every rules have a set of exceptions and you need to be very careful in the exam when you're dealing with an exception. You want to be aware of them. And then in the next unit, I'm going to use this information to work on that. We're going to use them to determine various things about reactions. They'll give you a balanced equation. They'll ask you certain questions about it. With oxidation numbers, you'll do that. Now, there's a body of people studying chemistry and they love this section. It's very much a game you play with numbers. It's a technique used by the chemist to decode various reactions. And it's the one area of chemistry where you may find yourself inside an exam centre and finding yourself using oxidation numbers without having been asked to do so. You may find, hang on a minute, I need to check this. And you'd use oxidation numbers to do that. And that's exactly what I'd like to think you would do. That you would be in a position to do that and that it would be the way you go about it. So I'm going to start then with oxidation numbers. This is all in your notes again, I'm reminding you, so please be aware of that. Oxidation numbers, the formal definition then I'm going to deal with now. Let me just put that on the screen for you as well. I'm aware that anything going on the projected screen is in note form as well, so I'm not too perturbed about that, but I do need you to be able to see at the same time what's happening here. The oxidation number of an element. Now, the examiner will ask you to define oxidation number. They will not ask you to define the oxidation number of an element. That's where you come in. You must realize that every element in every compound has an oxidation number. Let me write down a chemical formula for you. H3PO4. That's phosphoric acid. Hydrogen has an oxidation number, phosphorus has an oxidation number, and oxygen has an oxidation number. And you'd have to be in a position at the end of this section to be able to tell me what they are. Okay, so the oxidation number refers to a specific element. That's very important. I have it underlined. The oxidation number, you'll be asked to define oxidation number, and most people say oxidation number is the charge which an atom or an element has. That's a mistake. You have to say the oxidation number of an element. You're making it very clear, you know what you're talking about when you say that. The oxidation number of an element is the charge which an atom of that element has, assuming the compound is totally ionic. Okay, now that's a way of dealing with that. There's a number of definitions. I have a slightly different definition in your notes, and I'll ask you to modify it depending on which one you prefer. The oxidation number of an element is the charge which an atom of an element has or appears to have in a compound. We'll get to that in a moment. My preferred one is the one on the screen there. Okay, that if you assume everything is ionic, then it's easy to know what the charge of the elements are. Some things are not ionic, but for the purposes of assigning oxidation numbers, you will assume it's ionic. And based on that, you'll be doing very well. I would recommend that to you. In other words, you'll be changing that slightly, okay? That assuming that the compound is totally ionic, that's probably the better of the definitions that's there. There's another one in the text which says something along the lines of the oxidation number of an element is the charge which an atom of the element has when the electrons are distributed according to certain rules. No, I'm not mad about that one. It's vague. Okay, I think that's the best one, and it's a variation for what's in your notes. I'm just pointing that out to you, that you need to be aware of that when you're going through it, okay? Oxidation numbers are used to study, in the study of chemistry, to identify chemical change. So they're a tool that's used by the chemist in analysing various chemical compounds. And frankly, I have to tell you, it's a great assistance. You need to be very good at this now. You need to be sharp at it. You need to be aware, and every time, with no delay, you should be able to assign oxidation numbers to any compound like that. We'll get to that in due course now. I don't want to just go there yet. Now, I'm staying with the screen here for the moment. All this is in your notes. You're going to get the shortest set of rules you've ever got in your life here and in your notes. They're only phrases. Okay, and I don't think they'll be asking you to state these rules, but they'll discover very quickly if you're not familiar with any of them when you start to apply it. Starting off then, please, a free element has an oxidation number of 0. Always a free element. So what's a free element? If you had something like Cl2, it's an element on its own. right? It's an element on its own. So it would have an oxidation number of 0. You write it underneath like that. All gases are diatomic. You're okay with that, yeah? O2 would be 0 as well. H2 would be 0 as well. Okay, oxidation number 0. And indeed, if you have a solid, and by the way, more than half the periodic table are solids. If you have solids like copper, then the oxidation number is 0. It's a free element. It's on its own. It's not attached to anything. It's on its own. Okay, very important. Right? Are you clear on that then? And that's carbon, and that's 0 as well. So free elements have an oxidation number of 0 is the first rule. Very good. The next rule then is simple ions have an oxidation number that is equal to the charge. Now, are you okay with the idea of a simple ion? A simple ion is an ion with only one element in it. We've met a few already today. Okay, there's a simple ion, sodium. There's a simple ion, the chloride ion. Okay, here's a simple ion, calcium. It happens to be 2+, it's in group 2, it's a valency of 2. Will you be aware of that, please, okay, as you're going through it? And all that goes with that then is very important, I don't need to say. So the oxidation number for this is +1. The oxidation of this is -1. The oxidation of this is +2. Okay? Had I better get you something with a bigger charge in it? Well, you know, you'll have to be looking at things like there's aluminium and there's +3. Now, please, oxidation numbers, every one of them, with the exception of naught, of course, has a sign. Okay? There's no point telling me the oxidation number there now is 1. Okay? It's +1. Very important when you're doing that. So that's the rule. Simple ions have an oxidation number equal to the charge. Are you okay with that? Next step. Okay, the oxidation number, okay, for halogens in compounds, the oxidation number is always -1. Are you okay with the term halogen? Halogen is group 17 in the periodic table. Some of you might know it as group 7. The halogens, I'm talking about fluorine, chlorine, bromine and iodine. Yeah, they're non-metals, okay? And they're generally, by the way, the Murphy's and the Paddy-Murphy theory, they're at the end of the formula as they are, okay? So halogens in compounds, okay, will have that. So there's sodium chloride, okay? There is calcium fluoride, okay? And we'll just use the two of them, okay? So that's always -1, okay? That's -1, right? This one here, okay, that's a halogen, it's in a compound, that's -1, and you write it like that. Now, very important, you'd never write -2. It's the element is an element, okay? It is the charge which an atom of the element has. You'd never write -2 there, it would always be -1. Are we okay with that, everybody? That you're able to work your way through that. Now, be aware of that, please, in what we're doing, okay? That you'd never write -2 there, that's fine. That's that, and that's what we have. And that's that particular element, the halogens there, all right? Now, next. In most compounds, oxygen has an oxidation number of -2. In most compounds, oxygen is -2, okay? Now, I have written there exceptions. I like to take the exceptions separately. Learn the rules first and know them well. And then learn the exceptions. There's a handful of them there. You'll recognize them instantly once you're aware of that, okay? Just so we're going to say for the moment, oxygen in a compound is -2, okay? There you are. H2O, the oxygen is -2. Okay, very important. Oxygen is -2, okay? Very important, no matter where you are with that now. Calcium oxide, the oxygen is -2. By the way, the Paddy-Murphy theory here is very good. Okay, Murphy minus is at the back in all of them. As you print formula, generally speaking, with few exceptions, you'll find the minus is at the back. The only exception to that I can think of on your course is organic compounds. It won't arise here. Okay, just be aware of that the minus is at the back, and that's very useful for what you're doing there. So that's that particular rule, -2. The next one is oxygen in compounds has an oxidation number of -2. You have that one, yeah. And now hydrogen in compounds always has an oxidation number of +1. There are exceptions there again. Hydrogen in compounds. Now let me deal with that. There's hydrogen in a compound. I'd put +1 in there twice. Very good. Okay, that'll be good, right? Just to deal with that. Now, I don't want to put them all there together because it's just going to confuse you. It is easier to take them one at a time, and then we'll apply it in all sorts of ways to see that you're able for this. But there'll be a lot of issues here. I'm going to give you a lot of questions to be answered here in terms of what you're doing, and this is most important as you're going through it, okay? So in most compounds, hydrogen is +1, okay? So no matter what the compound is now, if you had H2SO4, that would be +1 twice. Why? Because you're going to say to me, there's a rule. By the way, the oxygen is -2, we've just said, okay? -2 4 times. That's very good as well. Okay, but that's a rule. Hydrogen is always +1. Very good. Okay, and it could come up in all sorts of things. It could be as simple as HCl, and that'll be +1. By the way, that's a halogen. That's a halogen. That'll be -1. There's a rule up there already about that. Okay, very good. Now the last two are rather important. And I just raise that a bit for you to make sure you're okay with that. Okay, the last two rules are rather important. Neutral molecules, the oxidation number of all atoms add up to 0. Okay, the oxidation number of all atoms in a neutral molecule. Okay, so I'm going to do that for you now, just to give you a sense of where you're going with that. If you had something like sodium chloride, very simple. Sodium chloride, very simple. Halogens are -1. The halogen is -1. Therefore, that must be +1, so that the whole lot adds up to 0. I'm going to say that again. There's a rule about that. There's a rule about that. That halogens in compounds is always -1. And we have a rule down here now that a neutral molecule, a molecule with no charge on it, then the numbers must add up to 0. So if that's -1, that's +1. Now, can I recommend this to you now, please? This is not standard notation, but where you deduce something, will you put a narrow down from it? It makes it tidier, right, in what you're doing. Let me give you the molecule we had a moment ago then. There's sulfuric acid, H2SO4. Okay, oxygen is -2. There's a rule about it there, multiplied by 4. Never write -8. Never ever write -8, -2 4 times. That's +1, write it twice. And therefore that would be +6. That has to be +6 because the whole lot must add up to 0. A rule, and that rule here, that they must add up to 0, tells you that the sulfur is 6 in that. That's very important that you have that. Are you okay with that? That's the idea. Now, we'll do a lot of them in a moment, but I just need you to get used to it first. And the last one at the bottom there then is complex ions. The oxidation numbers of all the atoms add up to the charge on the ion. Now, we had a simple ion a while ago. There's a simple ion. Here's a complex ion, SO4 2-. If there's more than one element in the ion, it's a complex ion. Okay, and we know that that's sulfate, and this is nitrate, and this is phosphate, PO4 3-. Okay, that's very important. And of course, the numbers must add up to the charge on the ion. We write the oxidation numbers underneath. Now guys, normally when I'd be doing this, I'd be advising you. I'm a bit concerned that you're able to read this, and I'm writing in black all the time for that reason. I think I'd be putting the oxidation numbers in a different color. I'm going to do that in a moment. In the exam, I might even do them in pencil. But make sure they're very legible and very clear, okay? And they must be very tidy. Now, if there's any ambiguity about what it might be, you won't get the marks. So you need to be very careful that you're working through correctly with that, okay? And that's most important you have. So I've given you these now, and I'm just looking at them. There's a complex ion. The oxidation numbers must add up to -3. The oxidation numbers must add up to -1. The oxidation numbers must add up to -2. And the oxidation numbers, that's a simple ion. I've put that there for simplicity, okay? That's a simple ion. These are the ones we're talking about. The oxidation numbers of all the atoms must add up to the charge on the ion. So here we go. We know oxygen is -2. By 4, that's -8. So I'm deducing, my arrow now, I'm deducing that phosphorus must be +5, because +5 and -8 gives me -3. Now that's it. Now that minus there, that's a Nerniism, by the way, okay? That's not standard notation. But I'm saying it's a good idea because what it does, it doesn't clutter things up for you. Okay, and I suggest you do that. So there's your 5, okay? There's your -8, so there's your -3, very good. This one, -2, 3 times. -6, that must be +5. The nitrogen must be +5. +5 and -6 is -1. Very good. And this one here, that's -2, 4 times. That's -8. So that must be +6. That must be +6. So that's -2. Now, attend to this, please. The same element could be in different ions and have different oxidation numbers. The same element. So there's no rule that sulfur is always 6 or 5 or something like that. Okay, you must be aware of that, and please be very aware when you're doing that. That's the last rule then. Can I briefly read through them again to make sure everybody's okay? And please, my advice to you now is very simple. Don't go near any application of this. Don't go near any application of this until you know those rules. And please, there's a hierarchy here. That one overrides that one, which I'll refer to in a moment now. Like, for example, halogens are -1. Okay, in there. Okay, and what about that then? Halogen is -1. No, that's a naught. Chlorine is a halogen, but the first rule tells you it's a free element. So number 1 overrides number 3. I did put in there halogens in compounds. And that's important that you be aware of that, all right? And so the simple rules are then, as written there for you, free elements, elements on their own, the oxidation number is always 0. Simple ions, ions with just one, there you are, a simple ion, will have an oxidation number equal to the charge. Okay? Halogens in compounds are always -1. Okay, always -1. There you are, there's a halogen, it's in a compound, always -1. Oxygen in compounds is always -2. There you are. There's oxygen in a compound right there. Compound, oxygen -2. Okay, very good. Next, hydrogen in compounds is always +1. Hydrogen is always +1. There you go. Hydrogen in a compound, always +1. Never write +2 there. It's 2 +1s. +1 is your answer there in that case. Okay, very good. And then the last two, which are very important. A neutral molecule, there's a neutral molecule, must add up to 0. That's a rule. That's a rule. -8 + 2 is -6, so that must be +6 and -6 to give you 0. Very good. And the last thing, complex ions, the oxidation numbers must add up to the charge on the ions. The charge on that ion is -3. We have a rule to say that oxygen is -2. That's -8. So that must be +5. -8 + 5 is -3. -6 + 5 is -1. -8 + 6 is -2. Very good. Now, this is nice, this is structured, and you have a lot of control over your outcome here. And I'm always encouraging students to go after questions where you have control over the outcome, where you're not suggesting possible answers. There's exact answers here, and if you're good at this, well, you tend to be very good at it, and that's what I'd like to think you'd be working with. Now, I have a series of little questions here in the notes, which I'm going to go through on the board with you, because I want to make sure you can deal with them. And I have them written like this, so I'm going to write them on the board again to make sure that everybody's okay with them. You're asked, what is the oxidation number of sulfur in each of the following? And I've given you all the following. SO4 2-, H2S, Na2S, SF6, Na2S2O3, S2O7 2-, and I'll put the other two down here, SO2 and Na2 S4O6. Now you have a total of 1, 2, 3, 4, 5, 6, 7, 8 compounds there, okay? And you'll be writing the answer down underneath in each case. Now, I have an issue with this, that I'd like to think that you'd use that set of examples when you're revising the section to see are you still getting them right. So my idea would be that you could cover the answers with your page and you could try and apply them again, even though you're taking them down now and you're putting the answers in, that you could cover them and check yourself again when you're revising, okay? And let's just see how that'll be. Now, I'm checking that your images are okay on the board, because I just need you to realize I'm working through this. I hope it's all right with you. It looks fine. Yeah, and I hope you can work through that, okay? Now, please, will you be aware, please, that they're all available in your notes now? They're all on the hard copy, right? And you're asked, what is the oxidation of sulfur in each? And I'm talking my way through it now. Okay, oxygen is -2 4 times. That's -8. So the sulfur must be +6. So I'm putting a +6 down there as the answer. Must add up to the charge on the ion. Are you okay with that, everybody? That's the first one. Good. That's the first one. Okay, the next one. Hydrogen is +1. That's a rule by 2. Therefore, the sulfur must be -2. -2 is the answer. Now I'd like to tell you, like if you wrote that in the exam, I can't guarantee you'll get the marks. You were asked a question, and the question was, what is the oxidation number of sulfur? You must tell the examiner that the oxidation number of sulfur is -2. You need to tell the examiner the answer, okay? Not just leave your working method there, even though it's fine, nothing wrong with it now, just be aware of that. Okay, this one then. Now I have to be careful with that one because we've no rule. I've it in there deliberately. Sodium sulfide. I'm going to write it here again for you now. Na2S is sodium sulfide. Okay, sodium sulfide. And I'm asking you now to be aware. The Paddy-Murphy theory is brilliant here. Okay, there is no rule about sodium, okay, and there's no rule about sulfur, so what are we to do? You could have endless rules on any circumstance, and you need to be careful with that. You could have endless rules, and I'm asking you just to be cautious about it, because we can't have endless rules. Group 1 elements, sodium, lithium, potassium, that lot there, they're always +1. They're on the left-hand side of the table. They're group 1. They lose 1 electron. They're all positive ions. That is, in fact, Na plus and S2 minus, if the truth is known. So I want you to know that there is no rule about it, but it's correct. That's always the plus, and it's a valency of 1. So that's +1 twice. So that must be -2. Okay, and I'm putting in the arrow to say I'm deducing that. I'd expect you to know that now. I'm putting it up here again. +1 twice. I'm deducing this, and this happens to be -2. Okay, this happens to be -2. Very good. Okay, the next one, there's a halogen fluorine. It's -1 by 6. Therefore, the sulfur must be +6. Okay, sorry, I must put in my -2 there. That's my +6, my answer there, +6. Now, this next compound, let me just segregate them for you. The next compound, I'm keen that you can, they're all in your notes now, I'm reminding you of that, and I hope you can read them. Sorry, now the one at the end here is a little bit vague, but I hope you're okay. Right, I'm going to write it down here again for you. It is Na2S2O3, that's sodium thiosulfate, very important reagent on your course. It'll be done in volumetric analysis 2. Okay, that's the redox of volumetric analysis to be done there. Okay, now here you have it. Oxygen is -2, a rule 3 times. I've just told you about the Paddy-Murphy theory. That's technically, that's P and that's M. That's sodium plus, and that's S2O3, 2 minus. There's a simple ion and a complex ion, okay? Now, you have 3 -2s for the oxygen. You have +1 for sodium twice. And look, that's where the arrow is very valuable now because it gets crowded. Okay? -6, +2, +4. And of course, +4 is not correct. Do you realize that? It is not correct. That's +4 for the 2. -6 +2 is +4. It should be reading +2 twice. The charge which an atom has. There's 2 sulfurs there, so each sulfur is +2. So the answer to that is +2. Now be very careful with that, please. That's a common mistake that people will write down +4 there. And +4 is not right because +4 is for the 2 sulfurs, right? And you don't want that. The last one here then, this is S2O7, 2 minus. And I'm putting my -2 in here 7 times, that's -14. So this must be +12, and I've just warned you, so it is +6 twice. So that's +6. I'll go back at that again now. Okay, you have S2O7, 2 minus. Now please, you don't need to have seen these ions before or be familiar with their chemistries to use this. You don't. All you need to be aware is that they gave you this and you must inspect it. The rule is oxygen is always -2. 7 -2s is -14. You want a total of -2 when you're finished, so the 2 of them must be +12. That's +6 each, so +6 is the answer for that. Are you okay with that? Good. Now please, I understand you need to practice them a few times, and my thinking now is that you would take your page and that you would cover the answers and you would try them again. Okay, very important. Now I'm going to do a second lot here, and I'm going to do them with nitrogen. I'll write in red this time down here, and I'll put the oxidation numbers in black. You have NaNO3. That's called sodium nitrate, by the way. You didn't need to know that now, but it is. This is NH4 plus. That's the ammonium ion. This is N2. That's the gas, N2. That's NH3. This is NH2OH. All given to you now, remember, they're given to you. There's no question of having to know these. NO, and this is N2O4, right? And we have to write the answers underneath on that now. We have to get they've asked you, what is the oxidation number of nitrogen in each of the following compounds? What is the oxidation of nitrogen in each of the following compounds, okay? And it's important that you'll be able to deal with that, and I'm just going to do that for you now, okay? And we're putting the answers down here then. Are you all right with that? Good. Now here we go again. That's -2 3 times. Now be careful. Sodium is +1. Can I remind you again? Na plus and NO3 minus. The Paddy-Murphy theory, the plus and the minus, the plus and the minus. So there's no rule about that, but it's correct. Will you be careful, please? There's no rule about it. That's sodium, okay? And sodium is +1. If that's +1 and that's -6, then that must be +5. Okay, +5 is the answer. This one is a complex ion. Hydrogen is +1 and it is 4 times. That's +4 altogether, so that must be -4. +4 -4. Am I right? No, I'm not. Are you aware? +4 +1, it must be -3. -3, okay? What is nitrogen in this? It's a free element, 0. There's your answer, 0 down here. Next one, now be careful, won't you, that you're dealing with separate. Okay, hydrogen is +1 3 times. +1 3 times, therefore that must be -3. -3 is the answer. Down here now, be careful. That's not anywhere complex, but you just need to be careful with it. I'm conscious now you can't see some of these on the screen. You have them in your notes, but I just want you to be aware of that. NH2OH, right? I'm working as follows then. Watch me, please. Hydrogen is +1. Oxygen is -2. Hydrogen is +1 twice. And you must deduce that, and the whole lot must add up to 0. The whole lot must add up to 0. +1, -2, and +2. +2 and -2 is 0. That's +1, so this must be -1. -1 is the answer. Are you okay? +1, +3 if you like, 3 hydrogens, +3 and -2 is going to give you +1. +1 and -1 gives you 0 because it's a neutral molecule. Now we've 2 oxides of nitrogen here. I'm very conscious now that you can't see them, but you have them in your notes. I keep telling you that. I'll write it down again for you here. It's NO, right? Oxygen is -2, therefore the nitrogen must be +2. +2 is your answer. And the last one, writing it down here again for you, N2O4, okay? And that's going to be -2 4 times. Therefore, that must be +4 each. Will you be careful? Will you be careful? Again, oxygen is -2 4 times is -8. Yeah, -8. And there you have it, +4 twice. So the answer is +4 now. Be careful. The answer here is +2. So your answers are +5, -3, 0, -3, -1, +2, and +4. And they are the answers for the oxidation numbers for that particular one. More than anything else, you have to try and work your way through that. Now, do you think you're okay with that? Do you think you're able to follow through on what we're dealing with there? What you've been asked now in your notes simply is, what is the oxidation number of an element in a particular set of compounds or a particular set of species? Some of them are ions, some of them are free elements, but you basically applied the rules. Now, I promise you, if there's any question here, and this is a very important point now, when you're revising these now, I've told you already 3, 6, you had 8 of these altogether. If you're getting 7 of the 8 right, you have a problem. That's not saying that's fairly good, 7 out of 8. That's a disaster. You either get them all right, or you're unfamiliar with the laws and the rules. Now, please, the idea of getting some of these right isn't on at all. Every time you revise this, you cover the answers, apply your rules. If you get all of them right, you're on top of this. Getting one wrong even means you're slipping up somewhere, you're unaware of some rule, and that has consequences in the exam. Now, please, you can be very good at this. And I'm encouraging you now to go at it with an attitude that you would be on top of it and you know exactly what you're doing when you apply it. Because if you do, I think you'll do fine in this. All right? Now, I'm going to break at that. And our next task now will be, of course, to use oxidation numbers in typical applications in chemistry. Okay? But you need to go back now and make sure first you're familiar with the rules and you know them quite well.